All right, next up, we have to duplicate this copper piece, except in a bunch of small pieces, because we're going to have removable sections that they can just replace as they get metal swarf all over them from the welding process, which you can see this copper piece has. And copper is usually pretty good at that. I don't know if they use some of that anti-spatter stuff, it would help, but maybe that would affect the laser operation. In any case, we need to duplicate this piece, and we need to make a channel in it. Of course, for whatever reason, the manufacturer chose to use really odd-sized material. So this is 0.570, not 0.625, which you can just order. So this is 0.625 aluminum. So the first thing I do is take it down to 0.570. Then I got to put a 10-degree bevel on it. And in order to do the 10-degree bevel, rather than knock my milling head out of tram to get the 10 degrees, every time I have to make these, since they want these to be a throwaway part and possibly more made in the future, I'm going to make some vise jaws that will fit in the vise that will hold the parts at 10 degrees, so I can, once I do this and make the vise jaws, I won't need to knock my milling head out of tram again. So I thought that'd be a good idea. And we've got two spacer pieces, one that goes on one side, one that goes on the other side, and this is the area where they're going to be welding. There are 4 of these, and these guys will get a channel down them, and then some way I need to get a tubing into the hole into the middle in order to get the argon gas for the back coverage, so that the back of the weld doesn't get oxidized. One unfortunate thing is that the set screw spacings on the machine that holds this long piece in is such that I need 11 inches. And that means the part itself is much narrower. So the part that'll go over here is much smaller, and it's going to go down to one end, which means I need to drill a hole to get to the channel that whole length. Or I can feed from the back like they did before. Haven't decided what solution I want to do yet. So we'll figure that one out when we get there. Here's the setup I intend on using on taking this stock down the 50 thousandths or so it needs to have removed. So first I'm putting a couple parallels. They're the width of this 1-inch material here. And then I'm going to put, and I need this bias so that I can measure the thickness off the end, at least for the first one. So that means this is going to be counterweighted, kind of funny. I could throw a jack, a machinist jack under it just to support it, which I might do just to keep it level, because the parallels keep moving. So I'm going to crank this down, tap it into place. That's nice and stiff. And then, and as an added bonus, the reason I left the inch on the end is to stiffen it up. The other solution would have been somehow to clamp it to the table, but there wouldn't be a lot of clamping space because I need to have the top. So then it could have been a super glue solution. I don't know. There were a lot of approaches to this. This one seemed like a good one to me. I'm open to suggestions. Please comment if you have good ideas. I always love to hear them. I'm going to use this face mill to face off both sides, and just so I've got nice finishes on both sides, I'm actually going to take off a little bit of material from each side. So it's going to be twice the work, just because I think it'll look a lot better, because this extruded finish is kind of rough. The other thing I'm doing is, you notice the cutter is not centered on the work, and what I'm hoping is that as the cut enters the work, it's mostly going to be in this direction now. As it exits the work, it's going to be perpendicular to, actually when it gets right here, it's going to start to be perpendicular to it. I'm trying to minimize the amount of vibration I might induce into this. May not be a great idea. We're just going to try it out. I realize now the inch longer part was silly, because if I remove material off if I remove material off both sides, this won't sit flat. So either I've got to leave the other side as is, or, yeah, I guess I got to leave the other side as is, or I'm going to have to clamp. I'm going to have to get the cutter to here, move the clamp over, and then finish the cut, which doesn't seem ideal either. Oh, kind of blew it. So all the material is going to have to come off one side. We're going to have an ugly side. For the next part, we might do a 50 thousandths pass. to see if I can just do the whole thing in one cut. It seems like I should be able to. This is going pretty easily. Here's the part finished. And I went and did a 50 thousandths cut back and forth here, and the loading caused the cutter to shift just slightly, and you can feel that. Now I'm gonna have to remake this piece. Well, it was a good lesson, right? If you're wondering what I was talking about, getting the force aimed towards the camera or down this part, you can see at the shape of this curve where it's cutting, it's initially coming in more straight than it is when it's exiting. And I thought maybe that would be good, maybe not. Turns out I can get by without the clamp. You can hear when you're at the far extremes that there's a little bit of ringing on it, but I think it's going to be acceptable. So in order to hold the parts that I'm going to make at 10-degree angle, I made some Kurt Weiss jaws, soft jaws that are much bigger than normal. And interestingly enough, the drawings I found, like these two, actually give dimensions that have the jaws when they're all the way down. Well, okay, it's not exactly true. So if you drill a 1/2 inch hole with a 3/4 inch countersink for the Allen head bolts, then the jaws don't reach. They've got some slop, but they don't reach the bottom of the jaw of the Kurt Weiss to sit flat on it, so they can be canted, especially when you tighten them, which is really annoying. One of the drawings actually had the hole, instead of 0.5 to be 0.530, and the countersink to be 0.730. Now I could do the 0.530, but the countersink at 0.730, I don't have a countersink that's 0.730. Mine are all 0.750, which is standard for one of these Allen screws. So I guess I have a couple options. I could drill the small hole larger and then take the Allen heads over to my lathe and turn them smaller. That way the jaws would have enough latitude to reach the base of the Kurt Weiss, and I could guarantee that they were flat when I tightened them. Or what I think I'm going to do is I'm just going to leave the 0.5 and 0.75 holes and then shim these guys up, because there is enough latitude to shim them up. So 10 thousandths shim guarantees they're sitting flat on the bottom of the vise, and then I won't have to worry about this. So I'm going to cut out some shims, put them under these jaws, and then tighten them up. The reason for this is because I'm going to put a 10-degree angle slot with a flat on the bottom in here to hold the parts I need to make. And if one side was higher than the other, then they'd have a slope to them, and one side would be thicker than the other. And with dovetails, you can't have a thick and a thin spot if the dovetails fit snugly. So we're going to get some shims, and we're going to shim these guys in. All right, so I've got the shim stock underneath here. Next time I'll just make these 10 thousandths longer, but I didn't know because I didn't know the dimensions. I guess I could have figured that out beforehand. But spring steel comes in a roll. At least this kind came in a roll rather than flat. And you see it's got a curvature to it, so it's actually a spring. So before I tighten these down, I figure I'm going to use my quill to hold this guy flat against the bottom, and then snug up the screws. That's a one. Now I just need to do this other one, but this time I've got to put the shim underneath, but remove it when I'm done, which might be challenging. We'll see. Oh, those slipped out nicely. So if I did this right, these jaws were machined to be the same size. I did run skim passes with them together. Oh, much better, much better. Oh, look at that. Oh, yes. So last time one side was up or the other side was up, depending on which set screw I tightened more. This is much better. This is a fairly consistent, only off by the tiniest amount on one side. I decided to do it again, this time using the quill to hold it down, and I was worried that was going to make it too tight, but we will see here. So I tighten them up, but I think now I can just drop these guys, drop the jaw back, and they should slide out, which they did. Perfect. Can we get better than just barely perceptible? I was just wondering. Yeah, there we go. All right. So how to set my quill at 10 degrees nod in this direction. So we want to take this and we want to rotate it 10 degrees in this direction. So the way I'm going to do that and get that right, just so you know, if I put a rod, like a 1/2 inch rod in here, I could create a parallelogram by putting the same angle facing the opposite direction mounted down here. So this is a 10 degree angle block. I'm going to nod this guy up this way because I want it to cut into the face jaw to make a shelf over here. I don't want the shelf on the moving jaw, I want the shelf here. So we're going to cut into this guy right here. So I've got this guy at 10 degrees. If I run an indicator up and down, take my quill up and down with the indicator on the indicator, right now it's obviously going to be, you know, if I get 0 here, it's going to be way off down here. But once I nod my head at 10 degrees, I will have created this virtual parallelogram. And once it's my indicator reads no change, then I will have my 10 degree angle set. Now, I've got a lot of potential compound errors here. The vice jaw, if it's not sitting perfectly flat, like there's a bit of debris on the bottom, I'm using parallels under a grinding vise. If there's anything inconsistencies there, like burrs or dirt, all to hold this 10 degree block here. Instead, if I wanted extreme accuracy, what I would do is I would take a sine plate and I would mount a vertical bar to it, set the sine plate at 10 degrees, mount that right on the surface of the mill and set that. I don't want to have to do this more than once because adjusting nod is much harder than rotation, because rotation, you know, your center of rotation is right in the middle, and so one side goes down a little bit, the other side goes up the same amount. With nod, one side goes down slower than the other side, or faster than the other side, as the case may be, and so it's a bit harder to adjust. Still completely doable, but I'm lazy, so I'm setting myself up. So if I have to make lots of these parts, I can just take these jaws out, put them in, and I'll have my 10 degree angle without having to worry about it again and retramming my head. For the knot on my mill, there's an adjustment, so I set it roughly to 10 degrees here. And then I put a 1/2 inch carbide bar in my quill and lined it up with the 10 degree angle block. You can see light just making it through there, and as I get this guy close, it's very, very close to perfect. Now if I need more accuracy than that, I put an indicator in here, go straight, take the quill up and down, it'll be up and down at a 10 degree angle and it should read 0. I don't need that accuracy for this project, but I might do it just for practice. I'm wondering where I got the precision carbide bar. It's a micro 100 6-inch, 1/2 inch bar, solid carbide. I figured they'd do a pretty good job of being accurate. If you need more accuracy, then you probably have to spend a whole lot more. So my rough adjustment got me within 2,000th over this range here, which is I guess about 3 inches, 3.5 inches kind of thing. That's surprisingly good considering it was a real quick rough estimate. I'm very pleased with how that turned out. So I'm going to see if I can get the rest of this dialed in. So I got this dialed in within 1/2 thousandth, much less than 1/2 thousandth over the whole range. And the way I iterated was I made an adjustment to the angle right there, more than 1,000th for 1,000th. And then I came down here with my y-axis adjust and re-zeroed, which is 15 on this indicator here, because that's sort of halfway through the travel. So I'd re-zero, and then I'd go over the travel again. And I'd just iterate that. The problem with this mill, and probably a lot of other mills, is when you tighten these things shift. So I tend to tighten them in steps, because if you tighten too much at one time, you tend to lose your setting. All right, so I've knotted the head up in the front, and what that does, even at my 6'5", it's hard to tighten the drawbar here, which is kind of amusing. But what this will allow is when I drill this shelf in the back fixed jaw, the parts will be held like this at 10 degrees, and when I come across after I retram my head straight across, I'll be putting a 10 degree chamfer on it. I can flip it 180, do the 10 degree chamfer on the other side, and I've got my dovetail. It'll speed this up because these are supposed to be expendable parts and they may want more of them in the future. So I'm making these jaws to speed that process up. So we're just going to start taking off some material and make our vise jaws. I'm going to do my first cuts with the jaws squeezed together like this, and that will get me my shelf, and it'll also put a shelf in the opposite side. Then what I'm going to do is I'm going to space these guys apart with like a parallel in the base of the jaws, tighten it, and then I'm going to continue cutting this guy down a bit further so that just becomes a flat surface with no shelf. I just want this to be able to push the part up against the fixed jaw. That's what I want. I'm going to try a pass with just a 1/4 inch depth. On the reverse pass, it was conventional milling, and I got some chip welding. Now I put a parallel between the vise jaws, tighten them up, and we're coming back and cleaning up the other side. Now I may clean it all the way up to my screw up here, and then what I'll have to do is take the vise jaw off and hit the face mill and remove some material. Otherwise, this will be too wide to hold the part. That was definitely a screw up on my part. So if it wasn't clear before, this shelf is lower, so you'll only have this flat part engaging the part being held in here. However, unfortunately, I got to take off, well, there you see how much material I need to take off of here so that this will engage, and I'll take off a little bit more. But you get the concept. Now when I retram my head and I come across here with a flat cutter, it's going to put a perfect 10-degree angle in there, as perfect as I am in my work. To tram in my vise, I use the Edge Technologies tramming tool. Works reasonably well. I'm pretty happy with it. The indicators don't reproduce every time when you lift up the indicator thing and drop it. They're fairly inexpensive indicators. They don't always come to the same value. I have the half thou indicators, and so they're picky, but yeah, they're not great at repeating. So first I set my 0 here, since I lifted that up. So usually I check a couple times to make sure that we're 0, and we are. Then you rotate around, and I use a gauge block. It comes with a magnet, but I don't use that. I bought a flat gauge block instead. You could just surface grind something. You just need something that's consistent. It doesn't have to be a particular thickness. It just needs to be consistent across its surface so that when you check this, so both of those are set to 0 now. So what I can do is, okay, so you can see as this one moves faster than this one, you can see that, and that's because we're nodding and the center of rotation is back. After going back and forth tightening the lockdown screws, we're back to within about 2/10. That's about as good as I can get it, because I get it right on the money, and then as you tighten, it shifts. And this whole thing, there's a huge lever arm between where you're tightening back here and where it moves up here. You got like 1.5 feet or 1/2 meter, and what that ends up meaning is very tiny changes back here lead to dramatic changes up here. That's one of the problems with this design. It's also part of its flexibility, but you got to live with it. Now you could try and pre-compensate, and I've done that before with only moderate success. Because of my screw up, I get to take the extra time it took to put the fixed jaws back on, load this guy back up. Now I got to take a face mill and take this guy down until the combination of these two parts, the spacing in here, will be less than the thickness of the other parts. Isn't that brilliant? That's brilliant. Only me. All right, so we're back and can load the part. This is the longest part. The rest are all much shorter. The ones I have to make lots of are, you know, 10 inches or 11 inches rather. So this is 12 inches long, so they'll easily fit in there. And you can see how it's holding nicely. A very solid fit along the whole length, and we can just mill off these corners here and get our dovetail.